Good morning everyone. Today we are going to present on facial recognitions. Our group leader is teaching you, and the member 1 is Weng, and the member 2 is me, Weng. So here are the agenda of this presentation slide. So for problem breakout, prosopagnosia, commonly known as face blindness, is a neurological disorder characterized by the inability to recognize familiar face, including those of friends, family members, and even one's own reflection. People with prosopagnosia often struggle with facial recognition, relying on other cues such as voice, hairstyle, or clothing to identify individuals. These conditions can significantly impact social interaction, personal relationship, and daily life. Facial recognition technology has gained considerable attention in recent years, thanks to advancement in artificial intelligence (AI) and computer vision, which enable accurate and efficient identification of individuals based on their facial features. Facial recognitions can assist individuals with prosopagnosia by providing visual cues and reminders, enhancing social interactions, and aiding in research and therapy, and more. So the objective of this final year's project are to provide assistance and support to individuals with prosopagnosia in recognizing and identifying familiar face. And the second objective is to develop real-time feedback mechanism that provide immediate information about the identified person to aid in recognition and improve social interactions. And the last objective is to contribute to research effort and a better understanding of prosopagnosia by utilizing the technology to gather data, quantify face recognition deficits, and improve knowledge about the conditions. So move to the methodology. Here's our data collect flowchart. First, we initialize the webcam and create face detection object named face detector using the vision case object detector class. Here we will show in the next section, which is program code. Then set the size of captured face image to 150 pixels and set the counter variable I to 0 to keep track of the number of captured face image. Capture a video frame from a webcam and store it in variable sample. Use the face detector object to detect face in the captured video frame. The result is stored in the variable box, which contains a bounding box of the detect face. Check if any face were detected by summing the value in box. If the sum is not equal to 0, it means at least one face was detected. Inside the if statement, check if the number of capture size image is greater than or equal to the desired size. If the size limit is reaches, break the loop and exist. Yes. So if the size limit is not reached, crop the first detector face from the sample using the bounding box coordinate in boxes, and resize the crop face image to fixed size of 227. And generate a unique file name for the capture face image using the current value of I and the .bmp extensions. Save the crop and resize face image as a bitmap image using the general file name and the I am right function. And increase the counter variable I by 1. Display the captured face image using the ISO and update the display. If no face was detected in the video frame, display the original frame using ISO and update the display. Replay from step 5 to step 15 until the sample size it reaches the maximum set size. So this is our training flowchart. First, we load the pre-trained AlexNet model into the variable G. Extract model of the AlexNet model and store them in the variable label. Replace the 33 layer with new fully connected layer. Replace the 35th layer with classification layer. Load image data from the storage using the image data store. Specify the data folder and label source. Configure training options using the optimizer, initial learning rate, maximum epoch, mini batch size in the variable or PTS, and train the network. So in here, in this step, maybe it will take a lot of time to train the network, depend on your CPU speed. So using the train network function with the image data layer and options. Last, we set the train network and end. So move to the last flowchart, which is testing. So first, we load the trainnet pre-trained neural network, initialize the webcam and create face detector and capture video frame. So if no face detected, then we'll display the label no face detector and repeat the step again. So if yes, then it will crop and resize the face image and classify the face image using the trained network. Then it will display the video frame with label and its confidence. Then repeat the step from 4 here to the step 10 here until the user stop the system.
So this is our course for our model. So first is the code for the collect data. First we declare the camera and then we create a face detection object that's named face detector. So we use the mission cascade object detector class, and then we go in and then we initialize the size and then the looping, and then in the loop, so it will the code will capture the video frame from the webcam and then store it in the variable sample, and then the cam will detect the faces in the capture video frame using the face detector. If there is the face captured, so it will generate a unique file name for the capture face image using the current value I and the .bmp as the extension, and then the crop and resize face image will save as the bitmap image using image write. So after that, the iteration will add on, and then if the iteration is larger or equal to the size, it will break the loop. And then after that, it will draw out means it will show the image on your screen, and then it keep update it. And then if there is no face, it also will show it out, and then but it will say there is no face. And then next is the training code. So we load the pre-trained LSNet convolutional neural network model into the variable G. So what is the LSNet? LSNet is a popular deep learning model that has been trained on a large image data set. So after that, we extract the layers of the LSNet model and store them into a variable layers. So in the layers, we replace the 33 layer of the model with our own layer. So the layer is the fully connected layer. And then these are our output neuron. This is based on we have how many data sets. So if at here we got 5, so we put 5. And then we also replace the 35 as the fifth layers as our classification layer. So after that, we will call the model to take all the image from our data storage. So it will include every subfolders in the data storage file, and then it will label the source from the folder names. After that, we declare the parameter for our model. So we use the SEVM, and then we set the initial learning rate as 0.001. Then the max approach is 20, and the minimum batch size is 24. So after we train the network, we set it as the train net. So next is the testing code. We load the train net we just now saved, and then we also open the cam, then open the face detector. So we go on the loop. So the cam will capture the image and put into the sample variable, and then the code will check if there is any faces detected in the captured image. So if there is no if there is faces in the image, it will crop the image and then resize it, and then it will classify the image with the training in, in into the training net, and then after that, it will calculate the maximum confidence value from our classification. So for here, we take the maximum confidence value because there will be other confidence value from the other data set, but the highest one means the most accurate one, the most similar one. So after that, it will display the original capture video frame using the image function, and then the title of the figure is set to show the printed class label and the corresponding confidence value. After that, if there is no face detected, so it also will show the capture video frame and also set the title to indicate there is no face was detected. That's all.
Hi, my name is Najwa. So I will present about the output for this project. So for the output one, the first phase detection the testing. So the program has detected the face successfully, which is me with the confidence level 99.9896%. So it has shown that the output can detect a face with high accuracy for the first testing result. So for the output two, for the second phase detection testing with sim Jing, the result has shown the confidence level is 99.0754%, which means that it also has a high accurate face detection for the second testing result. So the last output is for the last phase detection testing with teaching you. This result has shown the confidence level is 99.2805%, which means that it also has a high accurate phase detection for the last testing result. So based on the testing result, our program has high confidence level to predict and recognize for all the tested face. We can conclude that the face detection program has successfully implemented to recognize the face. Lastly, for the conclusions, we learned the object recognition using the deep learning model and motion and image subtraction to extract the training data, which is the face picture from the video to training model. So we also have the advantage. Using the deep learning model for the face detections and recognition can learn rich and complex representations of the face because it extracts the image from a large pixel image into many small pixels to train the model. So the small detail for each pixel will not involve into the training, but for the training process, we require a large amount of data to train the model, and it will depend to the computation power. So it also has a constraint. The most significant constraint is the background must be frame breakout before capturing the data sample, and the detection cannot detect the multiple face in the same frame. So next, this is a reference that have been used into our project. We have the 6 reference have been used. So that's all. Thank you.
So at first we got three files. First is the data collect and the training, and then the testing. So we already collect our data sample. After that, we train the neural network because this take a lot of time. So we already done it. So now is the testing. We test our model. So from here you can see there is my name teaching you, and then the confidence is about 80 until 90 and above percentage.
So the program has successfully to detect me /y is the confidence level is above 90%.
So during the testing, the model detect me, recognize me as Weng, and the confidence is about 100%.